Welcome to MS 100 lessons, and in this lesson I'll be doing work, which is a grade 12 content, and the outcome for this is to actually understand forces that do not do work. So now from the previous videos also we have identified the forces that do work, and we have also identified forces that do not do work, right? So the aim of this video is to actually explain why do we say forces do not do work, or some of the forces acting on an object do not do work. So with an aid of an example, let's say we have an object of mass 5 kg, okay? And then that object is resting on a horizontal surface at point A, and then on that object an applied force of 100 newtons is applied on the object, and that object moves from point A to point B, which is a distance of 5 meters. Okay, and then the condition of the surface, it's a smooth surface, so meaning that there is no friction. There is no friction between the object and the surface. Okay, so now we want to identify the forces that do work, and we also want to identify the forces that do not do work, right? And we do that by using a free body diagram. So if we draw a free body diagram for this object, we can see that the object has a mass, meaning that it has gravitational force. And we can see that the object is on a surface, then it means we have normal force, which is perpendicular to the surface. Since the surface is horizontal, then that will be the direction of the normal force. And we also have the applied force of 100 newtons. And we do not have friction because the surface is smooth, right? So these are the forces which are acting on the object. So this object moves from point A to point B, right? So now we want to identify the forces that are doing work and the forces that are not doing work, okay? So according to our rules, we have mentioned on our revision that if a force is in the direction of the displacement, it does positive work, right? But if the force opposes the direction of the displacement, it does negative work. So meaning that these two, they do work, but it's either positive work or negative work. But now the most important part for this video is this part here, is that if the force is perpendicular to the direction of the displacement, then the force does not do work at all. So now let us go back to the example, and then let us try to identify which forces do work and which forces do not do work. So now we can see that the object moved from point A to point B. So the direction of displacement is to the right. That is the direction of displacement, okay? So now we can see that your applied force is in the same direction as the displacement, meaning that it does work, and in this case it should be positive work, right? But we can see that the normal force is perpendicular to the direction of the displacement. That does not do work, and that does not do work. But now the aim is to actually explain why do we say these two forces, they do not do work, okay? So now if we can check our formula for calculating work, we said work done by a force, right? So in this case, that would be work done by that normal force. It would be equal to the normal force multiplied by the displacement cos the angle between the displacement and the normal force. So we can see that we can say the normal force multiplied by the displacement, right? And we have said that the displacement in this case is 5 meters. But now the important part is here on the angle between the two. The angle between the two, if it's perpendicular, then it means we have a 90 degrees angle there. So it means that the angle between your normal force and your displacement is 90 degrees. Okay, and if you can punch your calculator, 90 degrees equates to 0, then it means that would be your normal force multiplied by your displacement multiplied by 0, and everything would go to 0 joules. So this is the reason why forces that act perpendicular to the direction of motion or to the displacement, they do no work, because they will give you an angle of 90 degrees, and cos 90 degrees is equals to 0. So same thing applies to this gravitational force. If we want to calculate the work done by gravitational force in this scenario, okay, so it's in this scenario, then that would be the gravitational force multiplied by the displacement cos of the angle between the direction of the displacement and that force. So that would be Fg, which is what we can calculate, and that is delta x, which is a displacement, which is what is given, cos the angle between the two. The angle between your direction of motion or your direction of the displacement and your gravitational force is 90 degrees. They're perpendicular to each other. Then if this is the case, then that would mean that this is your gravitational force multiplied by your displacement multiplied by 0. So that this implies that everything will equate to 0. So it means in this case the work done by your gravitational force would be equal to 0. Okay. But however, now if we look at the applied force, if we try to calculate the work done by the applied force now, that would be work done by the applied force equals to that applied force, okay, multiplied by the displacement cos of the angle between the two. So your applied force was given as 100, okay, and your displacement was given as 5 meters, and the angle between the two, since they are going into the same direction, so since they're facing the same direction, so the angle between the two is 0 degrees, and cos of 0 is 1, so it means that would be 1 multiplied by 5, which is 5, multiplied by 100, which is 500, then that would be 500 joules. So it means there would be work done by your applied force, and we can see that the work done by the applied force is positive work. Why? Because it's in the same direction as the direction of the displacement. So now we have achieved our outcome to say that if the force is perpendicular to the displacement or to the direction of the displacement, the angle between the two is 90 degrees, and cos 90 would actually give us 0, and our final answer would be 0. So these forces which are perpendicular, they do not do work.